Let's now take a look at short options. Um, a short option, in a way, is like a poor man's European look-back option. Um, the reason for that is it's similar to a look-back option. However, the look-back option basically look at the entire history and and then choose the max and the mean. Where for the short option, the holder of the option only has one chance within the lifetime of the existence of the options to short. So once the holder of the option basically did the short to the writer of the option, then the price at the time that the short took place was recorded. Okay, so then at the end of life of the option, the holder, whatever the holds that short option, will receive either the usual payoff on European option or will receive the intrinsic value at the time of short, if that is greater. Okay, so therefore it provides value to the option itself. So it basically lock in certain profits, and it can do better than what you lock in. But there's only one chance to do that during the life of the option. Now, if we look at the payoff of a short option, it is really max 0 or ST minus S tau. Tau is the time that the short took place, and plus S tau minus K for call, for a short call. Why is that the case? Basically, this payoff function translates this statement here. And the reason is, if at the end of the day, at maturity, if the price is 0, meaning that, if the payoff or regular option is 0, meaning ST is less than S tau, then we basically have whatever we lock in here, okay? And now if this part is greater than 0, you see that by adding them together is really ST minus K, which is the payoff of the regular call. So therefore, this payoff function just translates this statement here. There's either the lock-in intrinsic value or the regular payoff of the regular payoff of the option, the payoff of a regular option. So similarly, you can see that this payoff function here specifies the payoff statement here for a short put option. Now, the payoff of short option is this. And then we can see some numerical examples. So let's say the short call has a strike price of $30. So the holder of the short price, called at when the stock price is 50. Now, typically you will say that for a short call, the short price must be greater than the strike price, because otherwise it doesn't make sense to short, right? And likewise, the short price must be less than the strike price for a short put. And otherwise, it doesn't make sense. So now, if that is the case, and at maturity, say that the realized price is 75, in this case, you will see that this basically is the same payoff as a regular call. because in this case that the realized price is higher than the short price. Now, if the realized price is lower than the short price, which is 50, then the maximum value is really the intrinsic value, which is 50 minus 30. So in this case, if the realized price is, say, some value like 45, the payoff will be 20. Similarly for a put, if the strike price is 30, and let's say somebody shorted at 20, if the realized price is lower than this short price, then it has a regular payoff. Then if the realized price is above 20, then in this case, the 30 minus 20 will be the payoff. Now you can see that if a short has taken place, the price of the short call after that is really the this value, which is the price at the time where the short took place, minus K for call, and plus the price of a regular call with the same maturity equal to the remaining maturity of the short option. But in this case, the strike price is changed to as tau. Okay, and for call, you will always have obviously S tau greater than or equal to K. Now the question is why this is the case. Why the short price is really the price of S tau minus K plus the price of a regular call with the same time to maturity, but the strike price adjusted to S tau. The reason for this is that a short call, for example, log in this S tau minus K value. So it's been locked in. And if for the remaining period of time, then the stock price is greater than S tau, then this, whatever you're locked in is still locked in, and you just add the additional value there, which will really just be the payoff of the regular option. And if, on the other hand, after that, the stock price somehow dropped at maturity lower than S tau, you really just get to this locked-in price or locked-in value here. So that's how that's why the price of a locked-in or price of a short call option is basically this locked-in value plus whatever the remain additional value you can have from the call, where if it's lower than the if the realized price is lower than this, then there's no additional value. So your locked in value becomes the maximum. So that's what it is. But if the value will continue to be greater, then obviously you can improve slightly from here, and which will get you the value of the regular call, because the regular call value is greater than the amount of value you already locked in. So similar analysis will occur for a short put, and so in that case, it's really the locked-in value, which is the K minus S tau, then plus the additional value you can still have, which is the value of a regular put with the same maturity, time to maturity, but then you have to change the strike price to S tau. Okay. Now, in general, for short options, because it actually occurs only at one time, and you don't know when that will occur, and you don't know when that person will actually make the short. The value of a short option really is not able to be calculated through a closed form formula, because you can't really easily derive what the distribution of the Shao value, the stock price occurred at the Shao value. Not like when you're deriving the price of X max or X mean. So in this case, even if you assume a relatively simple process followed by the underlying stock, you still have to go through numerical procedures to evaluate a short option.